meetup. So this feels very cozy. It's an actual meetup, huh? Like, no. But for those who don't know me, which is probably quite a few, my name is Paul. I used to be a content developer. As this scruffy beard turned me into DevOps engineer. But still, my heart goes into JavaScript and React specifically. Today, we're going to be looking into a bit of remix, a bit of testing, and then off to work. Isabel from InPay is hosting us, so big thanks. We have, and it's clearly girl hosting this because we're having some very fancy classes. So thank you. So then I'll just leave it to Isabel to present a bit of what they do here in InPay, and then Adrian will kick in with talking a bit about you. Thank you.
Welcome. I know everyone came for the cool stuff, so I will just make super short presentation, just what InPay is, so you know where you are. Welcome, of course. And I'm Isabel. I used to work with Paul. I tried to manage him. He managed me, which is why we're here today. I used to be a developer for 1 month. Was not good at it, so now I'm managing developers instead. Yeah, there are bathrooms here. In this little, there are 2 bathrooms here. If it's really, really like necessary, there are 2 more just under. After we're done, there will be some food downstairs also. And please help yourself to drinks and whatever. And if you need some help with any drinks, my boss stands here and he's the drinks expert. Okay, so just super short, in InPay, we do cross-border payments. Many do, so we of course try to do it smarter. There are like 3 aspects of why we think we do it smarter or why we do it smarter. And one thing is that we have one API to connect everything. So we have local clearing in 50 plus countries that you can connect to with our API. So it's super simple to hook up for us. And we have this mantra that cross-border payment should be as easy as sending an email for everyone. So not only those who have high needs, high money, high technology, but for everyone. We can do it really fast and quite cheap because we utilize all of the open banking systems that we have available for us to do. And then we have something really smart, is that we have a huge postal office network, meaning we can also do the cash to digital money transfer, which not only means we can hit like end customers in countries that do not have not even high technology, but just they maybe not have a credit card and stuff like that. So we can use the cash, and then we also can provide like a big turnaround for our not end users, but customers and clients like banks and postal office, making it easier for them to also take money the other way. So actually we both do payout and collection. That's like what we do. What is really special here is like our culture. It's just as important for us as the technology we use and our products. So I will just show a short video to show off a little bit like why it's so good to work here.
Hi, welcome to InPay. What makes working at InPay so special? Here at InPay, we like to do things together.
We eat breakfast together.
We food together.
We win together.
We hike together.
We shine together.
We fail together.
We learn together.
We explore together.
We grow together.
We run together.
We dance together. We cry together.
We laugh together.
We hang out together.
And we all like to celebrate together.
We are
This makes our solutions fully diverse and
Every day, we solve complex challenges together to democratize payments in every corner of the world.
we're best when it gets difficult. That's when we truly shine.
And right now, we are looking for new colleagues who are up for the challenge together with us.
So for sure, every company with respect for themselves in a scale-up phase have a super cringy video to try and bring more people in. Of course, we also do.
Hi.
That was the big picture. I just want to zoom in a little bit because the talk that we have from our side today, which will be Piotr here, is like one part of InPay, and I just want to give you a little fly-in so you will know how the technical setup is for us and from what Piotr will be talking. So we work in cross-border payments development. It's the big engine. We do it all. We have two backends. One old one we are trying to right now migrate everything to. That's why I just put it in black box because there's no need to go into details here. Now we are moving it up, trying to scale everything up and also like do it a little bit more professional. And what's interesting for today is we have three front-end platforms. Customer app, which is in React, collection client app in React, and then we have an admin panel that is hard React, hard on the view in Rails, but it's also being moved. Piotr will tell you more. So now you know what it looks like in our platform. Any easy questions? Cool.
Thank you.
as their lead software engineer. If you have a canteen at work, you might use Tampa as the management system, and if you don't, you can contact our sales team. I'm also a co-organizer of the Remix Copenhagen meetup, hence why I'm giving a talk about Remix. And it's also my first React meetup talk, so I think I kind of made it. Quite proud of myself. But Remix Copenhagen, we also have a meetup. It's going to be on the 22nd of June. It's going to be a workshop. First of all, I would like to know how many of you have heard about Remix. There's a bunch of people. How many of you have tried Remix? Not as many. So it's good because today we're going to have the very short and dirty introduction to Remix. I would like to thank my colleagues from the Remix Copenhagen meetup for doing some of the slides. I also contributed a bit. What does Remix do? Well, basically it just removes the big pile of problems that originates when fetching data in client-side components. I think all of us are used to having these components where you have to fetch some data, and then what do? Do you use Redux? Do you query and then have a global store? Or maybe do you use something smarter, React query, and then you fetch the data just in the components? But then when do you have to invalidate the data? What happens when you submit some data? There's all these issues that make a React app quite complex. And Remix solves all of this, or it makes it easier just by letting the router handle the data fetching and just providing a nice API around it, instead of having to figure out all these invalidations and all the mutations and whatnot. You just have to change a bit how you think about it and utilize the router, which is, let's say, the most used or the most shared package across React applications in a good way. This is from their website. It says that Remix is a full stack web framework, and then it lets you focus on the user interface and using some web standards and deliver a very nice experience. Remix has been made by Ryan Florence and Michael Jackson. They're also behind React Router. So they identified all the problems that people had with React Router, and then they tried to fix it with Remix. It was in closed beta for 1 year, and then it got released in November 2021. And it was open source, and then it was acquired by Shopify, which wanted to use it for their templating engine in last year in October. But it's still very much open source on GitHub. They're very transparent in all the decisions, and I recommend you give it a look. So what makes Remix so special is the nested routing system that they have, and I'll try to quickly explain it. We have an app here. We have the app folder, also with the root, and then some routes. Everything you see right here, it's basically the root, which is being rendered. And if we take a look, like in a hierarchy structure, we have the root, and everything else will be rendered inside it with an outlet. So if we have the roots folder, everything in here will be a route of the application. We have index, and then we have some node routes. But right now we are on the index route, which means that we are basically rendering the root one. And also inside we have the index component route, which is being rendered. If we are to navigate to, let's say, nodes, in this case, now we actually went two components in two routes, because we have the root, we also have the nodes, as you can see in the URL, and also we have the index of the nodes. So now we're rendering, in a way, three routes as for Remix. And I'll get why this is very nice to use. Let's navigate a bit more. We have the new one. Nothing else changed. We are in the same layout that we have right here, but now we're navigating to the new one, which means that now we're rendering this route, and this component here has changed. And if we go to the last one, which is the one with this weird node ID in the name of the file, this is the dynamic segment, which allows you to pass in, for example, here the ID of the node, and then use that param to fetch the data that you need. And to explain what happens when you have one of these routes. A route is mostly composed of a loader, a view, and the action, and some other things that don't really make sense in the introduction. But one route, it's basically one file. It has all these functions here. The loader is the one that handles the data fetching on the server side. The default export is the component that renders the data, and the action is the function that will then intercept any post, put, or any other request that you made from the default function. And then there's also some cool things if you want to do some error handling, or if you want to import some meta tags on the route. But what happens when you do the first page request, when you just navigate to somewhere, Remix, what we will do in behind the scenes, it will load all the loaders from all the pages that you have in the URL, because they're split by those names. It does that in parallel, and then it creates an HTML element with all those views and the data that it composes, and then it of course adds some JavaScript tags, and then it just sends to the browser, so it's very fast. You get the first page rendered very fast, and then you'll also have React on top, so that on the next navigation you actually just do a request to that loader, and then you just change the data in the client side. Whenever you do a post request, then you call the action. And the cool part is that if you were to do a post request in a normal React application, let's say you want to remove something, and then you would have to invalidate all the other queries or whatever data where you had that stored. Well, Remix makes it very easy. Whenever you do a post request, an action will handle it, and then it will just invalidate and refetch all the loaders in that path, so that you make sure that everything is in sync with the server side state. And then of course the views will also update based on that. Now let's try some demo time. See if this works. What I have here is one of the Remix stacks. They have these pre-made apps that you can basically just install by running a command, and they have some really nice examples that you can play around with. In this stack is one of the easiest ones to use. It's really good for MVPs. It's running, I think, Prisma. Yeah, it has Prisma for the ORM, and it has a MySQL database for SQLite. But this is the app that we had before. As you can see, we are on Notes. Let's see how that looks in Remix. If we go to Routes, we go to Notes. We have the loader. Can you see, or should I zoom in? We have the loader. This is the one that handles getting all the nodes. So we get the actual request, the GET request, we get the ID from the token or session, whatever, where it's stored, maybe a cookie, and then we fetch all the nodes from the database. This is going to query our database using Prisma. And then what we do, we return it as JSON. Basically, we're creating an API, and now with the default function, we are getting the data using this hook, use loader data. It's pretty cool that we can use the type of the loader, so we know exactly what data, what type we're getting from our server side, and then we use this in the JSX part. Basically, what this file renders is the sidebar here, also with the header, and then at the end it renders this outlet, which kind of makes space for the child routes to render. So now if we are to navigate to my second node, now what we are doing is that we are going to this page, the one with the node ID. As you can see, we have this very ugly ID up here. Let me know if I'm too fast. What we do is get the ID from the params. and then we fetch the node with this ID from the database, and then we return it so that we can just render this very small thing, which will render the body of the node and also the delete body. So what you see right. Then you can also switch routes. This is an example of error handling. It's the same file that I showed you before. Nothing has changed, but it has this error boundary at the end. If something for some reason fails during our when we load the data, in this case I did write it myself. I'm just throwing an error. We're going to catch it here, and we're not going to break the whole app. We're going to break just locally the route that has this problem. So then our app works as expected. It's just a small thing that that breaks. When we perform an action, for example, here when we try to delete a node, this is done with in a very weird way. Probably you have never seen a form for deleting something, and then you have a button inside. It used to be more common, but not as much anymore. But we will make a submit with this form, which will then call this action. It will get again the node ID from the params from the route, and then it will try to delete the node, and then you can see here it will try to redirect. So it's really cool that you can do all these interactions. It's very easy to specify what it should do. So if you try to delete the node is deleted, and this let's try adding another one. I'm too fast, sorry. So now if we try to delete this one, you'll see that we have a we have a post request to delete the route, and then we have the root, which was invalidated. So we fetch again whatever was on the root. You can make rules not to do this anymore, but we also get the new nodes with the one that is missing. So basically we invalidated the nodes loader so that now our app is in sync with the server. I actually moved very, very fast, but if you have any questions or any...
You were talking about not refetching loaders or revalidation before? What is that?
If you want not to refetch a loader, there are some I think it was called should revalidate, and then you can basically, I don't know how it's called right now. Cocolas is not helping me. But you can tell that if you want one route to be invalidated or not, or if you want to be if you want to load it again when something happens, and you can add some rules. Maybe you don't want to revalidate it if you post one kind of action, so you can do some logic in there. But I think this was my very dirty and short introduction to Remix. Thank you very much. And I'm waiting for all of you at the Remix Copenhagen meetup, 22nd of June, Roblox. Thank you.
But you said that it renders server side, and then it hydrates afterwards.
Yeah.
Does it send the full front end so that it can do client side rendering needed?
So in the first render, it builds everything server side, and then it sends it as HTML, and then it has just the GS tags for React, and then you get the full page, and then you also get React on top afterwards. So the next GET request, this one for example, this will be this is already client side.
Okay, so it just sits enough React to know how to paste that part. My other question is, you showed us an example with handlers, but if you need multiple handlers?
If you need multiple handlers, I can put them in the URL.
No, like in handlers for port requests, for example. If you have two forms in the same page,
yes.
I don't know why would you do that?
Yes. Well, in a post, you can actually call. Of course, you can do many things. One of which would be that you would have this, let's say, method, and then here in the action, you can actually get it, and if you say Cucolas data is request. The one with the form data, and then you have to wait for it, and then you can actually get the request that you wanted. So then you can get data. Yes, and then you can switch and do, with one action, you can do multiple things. Otherwise, you can also create an API endpoint like you would do in maybe Next.js. And then here, you can specify for this action, don't post to the same route. Maybe you want to post to somewhere else, and then you can define here where it should post.
You can have multiple buttons inside a form as well, and have different put the action on the button. You can have like form action. Yeah, so you're gonna have a delete and an edit next to each other in the same form. Maybe I'm a little bit confused because I'm following the same pattern with press. It has to be named handler, like the thing that handler function. So it's a single name that you can use, and then you can either pass a single lambda function or an object with multiple handlers. We are doing from HTML. Yeah.
So this is very close to the actual HTML form standard and how it used to be used in PHP. And
the best thing about Remix is it just links you to the MDN, the Brazilian network, our standard.
No, so what you could do, for example, if you were to do the infinite scrolling, one thing that is very common is that maybe you would have here in the URL, you would have page number. And then whenever you basically update the URL, then you would recall that loader. Because it gets new data, it gets a new param, so that it will try to recall. Remix also has this thing called fetcher, which it goes a bit into depth, but you can basically fake update the URL so that you don't have to actually display on what page you are, and you can do infinite scrolling without updating the URL. Yes. Yeah. I'm not completely sure about what's the plan with the server components at the moment, but you can do some cool things. It's called the API is called defer, and what you could do is you could defer here. You could defer the response, and then you could suspense await it in the component, so that basically you could stream the response and then you can handle that loading however you want. So it's not server component, but it is close to that.
Lars?
So with these files containing both server code and client code, how do you write tests for either of those two things?
That's a very good question. So if we look at the test that they already created here, test. Okay, they didn't really create any tests. But what you could do, of course, is what we had is a separate test folder, and then you can test the loaders that they return the data that you want, basically like testing an API and also the actions, and then you can also have unit tests for the different components.
And how do you mock the requests? So Remix is creating these requests behind your back, right? So you don't really know exactly how the request looks like. So I'm just wondering how you mock it.
Well, you know exactly how the request looks like. You have here in the loader, you know exactly what you're getting from this is an HTTP request.
Right.
And then so that can easily be mocked.
Yeah.
And then you can just pass in whatever token cookie you need.
Okay.
And then you just have to mock the database here.
Yeah, I think they showed in the smoke map.
Oh, was it? Oh, yeah.
This is more like an instance.
This is more like an
It's definitely an test.
yeah. But you can mock the data.
Yeah. Thanks.
Thank you. So how to run 1,000 tests in a second? All right, I have to say it like I never loved tests, but through blood, tears, and a very interesting product manager or owner, team lead as well, I learned to like tests because I stopped loving incidents in production. So I'll let today you'll have my favorite person that talks about tests, and I'll just stop saying anything else. It's Lars' talk. So please give
Thank you. So my name is Lars, and I would like to start by asking how many of you are writing tests on a daily basis? Weekly? Quite a few. Yeah, this is fine. And how many of you would like your test to run faster? All right, very leading question. Right, so my name is Lars Thorup. I am a software developer. These days, I mostly work with JavaScript, TypeScript, and Python on the back end. I've been doing test-driven development for many years, so I see tests more as a nice way to write code. So I hope it's also a good thing that it tests your code, but it's also a good way to design your code, I feel. So that's my approach. And I have been working also as a founder for several companies and doing coaching of agile engineering practices. And currently my day job is at invertbio.com, which is a bioscience or IT company. So we create services for bioscience industry. And you can find me on Twitter and on GitHub as Lars Thorup. I just want to show briefly, I do run a blog on fullstackagile.eu. So I write about various things, not only testing, but there are quite a few blog posts about testing in there, which you might want to check out. And I will also just very quickly say something about Invert, which is a company that started a little over a year ago. I'm a full stack developer here, and we take data from bioreactors, which is what bioscientists use fermentation in large tanks and to create molecules. And then we help the scientists to understand and analyze those data and try to do better predictions on the fermentation process, which is a long-running process with live organisms, so it's quite messy. So providing good data is nice. So that's what we do. The background for this test is that I've got the feeling that my tests have become slow recently. So a couple of years ago, I was a company I was a CTO. We had very fast front-end unit tests. So we were able to run many hundreds of tests per second. And I did that for like 4 years, and it was just very nice to have these very fast feedback loop on all your code. And then this was no longer with that company, and for the last couple of years, I've been working on various projects, and they have all been using Jest and the React testing library and JSDOM for writing tests. And this is a nice API, the React testing library especially, so I quite enjoyed it. But the tests tend to be quite slow, and I'm happy if I can run 1 test per second. So something happened. What is going on? This can't be true. We are trying to make progress in this industry, right? We're not trying to go backwards. So just to give you a visual indication, I have these small recordings. So the top one is my previous company. We had 1,553 tests when I did this recording, and we were able to run those in 4 seconds, running Mocha and Enzyme. And actually, it doesn't have anything to do with either Mocha or a little bit to do with Enzyme. And I'll talk more about that. And the second GIF is my current day job, where we are having a React testing library, and we are able to run 89 tests in 80 seconds. It's just so slow. Why is that? So what is the problem? And a lot of people that I talk with think that Jest is probably really slow, And it is true that Jest is slower than the new kid on the block called Vitest, which is faster, but it's actually not that. That is not where the problem is. And it's also not just React testing library, which we didn't use before and are using these days. The primary reason for the testing being slow is that we are including the DOM in all our tests. So so this is a way of illustrating like a performance chart, how much time is spent in each of the various layers when we are running tests. And this is not completely accurate. It's not. I didn't do any measurements. This is just from the experience of the rest of this talk. But basically, when you run the test or Jest, it's just a tiny bit of of the time that's been spent. Also, our code, this is the green one here, just a tiny bit of the time it takes. Also, React itself is also just a tiny bit. React testing library takes a little bit more because React testing library goes to great lengths to simulate a real user. So instead of just doing a click, they do both the mouse down and mouse up. And when you do typing, it does send a bunch of events to your form through the DOM. And that will also obviously take some time. But most of the time is spent inside the browser. Either it's a real browser if you're running your unit tests in a real browser, or it's typically JS DOM. That has to get all that HTML, parse it, render it, re-render it, update the styling, do all the things that browsers do, which end up taking up a lot of time. And that's not necessarily bad, except that it takes a lot of time. In general, we say that we should, when we do testing, we should strive to have a lot of unit tests because they are fast and robust. We should have very few end-to-end tests because they are very slow. And I'm not going to talk about end-to-end testing today, but I can do that another day because that can also be fast. And then we probably also should have some integration tests that test the integration of various layers, but are still somewhat faster and somewhat more robust. And when we use JS DOM, we are really writing integration tests because most of the code we are running is not our own code. So if we want to have more unit-like testing, then we should find a way to test our code without involving the DOM. So the question is, how can we still use our own code, interact with React, like our code is very tightly intertwined with how React works, so we cannot like extract it. We could in theory, but I don't think we want. So we want to still use React, but we don't want to use the underlying DOM. And then we should probably still keep a few integration tests, and we can use React testing library for that, to have a few integration tests because we do want to know that our routing works, and we need a real browser to really test the routing. We also do need to test some things like drag and drop maybe. It could be something where we actually do want to have a real browser where we can test. So I'm not saying we shouldn't use React testing library and the real DOM. We should just focus more on having faster tests for most of our code. So for that purpose, I'm introducing in this talk a library called React Test Renderer that apparently nobody knows about. And I used to use a library called Enzyme, which was made by Airbnb back in the days, and is no longer really well supported. It only runs with React up to version 16, and they have no plans to support it anymore. So I couldn't use Enzyme like I used to do. So I had to look for something else. And then I stumbled upon React Test Renderer, which is actually built by Facebook, just like React. And it's actually included inside the Facebook React repo as one of the packages. So they ship React Test Renderer with React. So every new release of React has a compatible version of React Test Renderer included with it. Of course, there's no guarantee that that will continue to be the case, but I'm pretty sure that the React team uses React Test Renderer for all the internal testing, maybe not just of React, but also of some of the Facebook code that uses React, because it's just a quite nice testing library. And React Test Renderer has a little bit of the things that React Testing Library do, one of the best things about React Testing Library are the queries that you can render something and then you can query for that button, or you can query for that text, or query by something and figure out whether it's on the page or not. And React Test Renderer has also some of these queries, like find by props and find by type, and I'm going to show a little bit more in detail. But the good thing about React Test Renderer is that it's really fast because there is no DOM. So you can run thousands of tests per second. I have a demo here in React Test Renderer Sandbox on my GitHub, and you can see this is the output from GitHub, from the GitHub action, where we are running. The most realistic one is the deep one here. So it's a quite simple test, but I can run 10,000 tests in 2 seconds. That's about 5,000 tests per second. This is just a playground, so I'm also going to show you a more realistic example. And we can actually just, so it's not only slides, we can also try to run it here. So here I have the React Test Renderer Sandbox running, the test. And you can see on my machine, which is a little bit slower than the GitHub Action runner, I can run 10,000 tests in 2 seconds. That's also 5,000 tests per second. All right, and the way I do 10,000 tests is that I just have a for loop, so I just run the same test 10,000 times. So it's quite a bit of cheating, but it's still very realistic. So let me show you how React Test Renderer tests look like. So here is an old favorite of demos, the counter. So here's a counter component that has a state, and it has a click handler. It has a button with that click handler attached. I'm not good friends with this. And then inside the button, there's a span, so you can say what the count is, and it will update on every click. And if I want to write a test for this, I will create an instance of the count component. This looks very much like the render method in React Testing Library. And then I can do find by type to find the button element. And the button element is not in the DOM because I'm not using the DOM. So I just interact directly with my components. So to click the button, I actually invoke the onClick prop on the button element, or like that. And then because then I can verify that the count is now 1 by going to the button again, finding their children, which is the span element, and finding their children, which is their text element inside it, and verify that it's equal to count. So as you can see, this is more low level than React Testing Library. So you have to be a little closer to the code. That's how unit testing is. But it still looks quite a bit like you are used to from React Testing Library. So I wanted to do a more realistic comparison where I'm comparing React Test Renderer against React Testing Library. So I created a sample app which has a somewhat simple DOM, but had a quite realistic user flow. So you have, there's a login page, there's a table with a lot of data, and you can edit the data, and there are tests for all these various scenarios. And I have linked to that demo here. And there is another difference, which is that React Test Renderer, I had to split the test into one test per page, where with React Testing Library, it's just one single test for the entire flow of the application. You can do that with React Testing Library because you have a real browser, so navigation works. You can't do that with React Test Renderer because there is no browser, so routing doesn't work. So you have to have a test per page, basically. But I'll show you how you can still test your routing, even though routing is not actually being done. So here we are looking at some examples. This is my machine, and this is the GitHub action. And you have to divide by 5 to compare these reasonably. But the end result is that React Test Renderer is 50 to 150 times faster than React Testing Library. Basically 2 orders of magnitude, which is nice. don't get 2 factors of orders of magnitude for free. So there are some trade-offs. As you saw, you have to invoke component event handlers directly. That means that if you are relying on an event with a prevent default, for example, you have to pass in an object that has a prevent default method, because this is not the DOM. So the DOM will not generate these event handlers for you. And also, in your code, you might depend on various DOM features that you use. Adding and removing event listeners in a use effect is quite common. Doing get element by ID in form handling is quite common. Using scroll to make navigation work smoothly is also quite common. Those do not exist when you use React Test Renderer. So you have to create a global.window object that has these things and mock them in proper ways. So there are some trade-offs. And before I do this, I will actually like to show you a code example. So this is the test that was 150 times faster on my machine than React Testing Library. And I'm just going to quickly scroll down over it. So this loops 300 times to be able to easily compare. I do some location mocking, which is the window.location that I mock. Otherwise, this is just a normal setup. So I have a Redux store. I do render my app component here. I can look into the state and verify that the user is initially not logged in. I can find things in the page by looking up for finding the sign-in button. Or I can, again, click the button, and here I use the prevent default mocking to avoid my code calls prevent default, so it expects it to be on the event. And at the end, I expect that the replace function, which is the history replace, the browser history replace function, has been called with the sign-in path. So what this test is testing is that if I click on the sign-in button, then I'm being navigated to the sign-in to the sign-in page. And then in the next test, I just mock the location to be the sign-in page, and then I can continue my testing from there. So again, this is a little bit more low level, a little bit more primitive, but basically it's the same thing. So I log in on this page by finding the proper input form and doing on change instead of on click on that form element, trying to type something wrong. You can see how the unchange takes full event object with the target.value, submit the form, verify that it says authorizing, and then verifying after some time that the authorization failed because the password was wrong, and et cetera, et cetera. This looks like just normal testing. So it's a little bit different, but it's not basically very different. And then you can just run 1,500 tests in 4 seconds of these very realistic tests, and have a much nicer time. That's it. But please ask questions. Yes.
Given that we are using React Test Renderer and you are sort of introducing it today because not many people knows about it,
yeah.
Where do people find knowledge about this besides just going to the source and reading?
That's a good question. So of course, with any technology that is not widely used, there is a risk in this not being really dependable. There are a handful of good blog posts, so other people are using it. Facebook has not written a lot about it themselves. There is documentation to be found. Facebook, GitHub, Test Renderer. This is documented, so this is actually not true. Here is the documentation. So you can find code samples, you can find the API description. It's not a lot, but I mean, there is a little bit And it looks to me like they are depending on it themselves. So I think it will be there and would, in general, will work. I have not had any issues. I have introduced it also in invert or where work, just for a tiny bit. I will want to spread it out more, but we have had no issues. Yes.
And is it updated at React?
Sorry?
The documentation updated at React?
No. So this is not migrated to the new React documentation site yet. So this still lives at the old documentation site. React is in the process of transitioning. They have other pages that have not transitioned yet. So this is one of the probably very low priority versions. Yeah. Question?
I just wanted having used recall in production and used flow in production, I want to say be very careful about the use of Facebook products. Besides that, having such a testing library that is not really mocking the real DOM, isn't it gonna? Because I have just been sitting here for the last 2 weeks implementing infinite scroll in Remix, but I would not be able to test that unless I actually mock a full intersection of server in the DOM thing, right?
So I think
that would be like a big disconnect between what the web page is doing and what you're actually testing.
Yeah. So for these kind of pieces of code where you are doing finely detailed interactions with the DOM, I think you need to include the DOM in your test. But in my experience, in like 99% of your code base, you are just doing ordinary React code, Redux code, data manipulations, visualizing stuff. So for the large majority of your tests, you don't need the close interaction with the DOM. And you might still touch the DOM because you'd still have these scroll event handlers that you're attached to, but you would just mock those in your test and not worry about the scrolling part and then test the scrolling part somewhere else instead of having to test the scrolling in every single test, which will slow them down. So that's my thought process.
I buy that. That's great.
Yeah, like I was basically kind of thinking the same, that you're working on the virtual DOM.
I'm working on the virtual DOM. So the element tree that React generates and then hands off to React DOM library, which will then actually render it into the DOM.
Yeah.
So we are not even using the React DOM library. We're only using the React proper library.
So I was kind of thinking like, okay, so if I use this, but then for the final test before I launch it into production, I run like a proper test, I would have to write both of them, right? But wouldn't it be also possible to just write a library that would do it in Mocha or another testing library, but then also translate it to like React testing instead, and then run like some passes on that. And then when you finally want to go into production, you can do like a final pass. Something you don't do that often.
So I would rather write tests for 95% of my code using React testing test renderer, like the fast one here. So like all my logic, data manipulation logic, and do I need to render this button or not, or should I conditionally render this or that? All that logic I would test with React test renderer. And then I would have 5% of my tests being written with React testing library. And all of those tests I would run all the time. So it will still take 10 seconds to run the fast tests, and then another 10 seconds to run the very slow 10 integration tests with React testing library. But I would run them both on every merge to master or every release or every push.
I have another question. So, like, there's a lot of feelings when it comes to like testing and test-driven development. I'm sure that you can face that also often.
Yeah.
But I thought it would be really interesting to hear from a guy like you. What would you not test?
Can I answer a different question? So,
okay.
So do we still need to have manual testing? Because that's I see there's a lot of value in manual testing. Because what you do with automated testing like this is that you're only testing the scenarios you already think about. and usually half the bugs that you will find, they will be things that you as a developer didn't think about. So you will also not think about writing a test for it. So somebody else have to find those bugs, and it can be your users. They will be so happy, or it can be manual testing, which needs to be creative, where you try all kinds of different combinations of things that people never think about to find those issues. And then you can, if you find something that doesn't work, then you can of course create an automated test for that. I don't think there are things that I would not test if it's important enough. But I generally dislike testing things that exist in code that I did not write myself. So for example, in Invert, we use a charting library, we use vcharts. It works kind of okay for us. And it does a lot of things. And I don't really worry about how it works and how it renders SVG. I only worry about do we send the right parameters to vcharts, and then it's vchart's job to render a chart. So I don't know if that answers your question.
I think it was more like, you can test things with tests that you write. Are there anything where like you would think, okay, this is like over-testing?
There's definitely something called over-testing, yeah. So I don't go for 100% test coverage, for example. I'm totally happy with 80% test coverage. I think testing is also just a thing you have to spend time on. And you have so many other things you also want to spend time on. So it's a trade-off, how much time do you want to invest in your test versus how many bugs do you want your users to find later. And so there are definitely things I'm not really, so like simple things that of course will work, things that have no if statements and no loops, I don't worry about writing tests for those.
Thank you. So I guess it's time to kick it off with the last talk of the day. Piotr here is going to talk about mock service worker. How many of you know what that is? How many of you used it? Okay, not that many. Then you're going to be in for a feast. So let's give a round of applause. And then,
Okay, can everyone hear me in the back? Just okay. My name is Piotr Zywien. I've been working here for 2 months now, and I'm going to tell you something about mock service workers. And I would like to thank Violeta Gluza for putting this presentation together. Okay, so basically, have you ever needed to mock some endpoints, some data, and not had access to the development resources or internet connection or what have you in order to test your front end components? And that is actually what this is about. Basically, mock service workers give you data that you need when you need it, so you don't have to rely on external factors. Basically, as I said, you want to isolate your backend and frontend. Mock service workers can help. If you want to test your components in different conditions, maybe you're testing edge cases or something weird like that, mock service workers can help. And if you don't have an internet connection and just for some reason need to develop right now, mock service workers can help there as well. Basically, here in InPay, we are already using mock service workers in one of our apps, and we are planning to use it in another app, which is the app that is split between Ruby and React code. So there are lessons learned from something called the customer app, without giving too much away. And this is what we plan to implement in our app. Basically, we've made a little plan of understanding what they are, just reading up on the documentation, figuring out what they can do for us, and today as well, we've come up with some zany scenarios where we could use them. Configuration, and then creating the handlers for each of the endpoints, and then integration into our basically what we needed to do is understanding what they actually do, what the integration impact is, and the maintenance requirements, and luckily those are quite negligible. It pretty much works out of the box, so that's nice, and it's very compatible with our React. They can help us here in InPay because sometimes when we don't have enough resources to write JSON endpoints, we can just go ahead and create the components that we wish to implement and not have to worry about waiting or blockages and stuff like that. Basically, what usually is, at least according to their documentation, mock service workers are run in development mode. We have to set them up and sorry. So the main part is creating the handlers, which is basically a mapping of an endpoint, the method of the endpoint, whether it's a get endpoint, a post, and so on, that will respond to any requests coming from the front end, and they will return a JSON content and status code and so on. Basically, there are two ways of integrating. One is the browser integration, which lives on the front end, and you can start a worker from the front end, and also you can take the root of the server where the implementation is run on the node level. Personally, for the example, I have a small, tiny demo. I have chosen to use the browser way because it just works. So this is how we map endpoints. This is a array of handlers. Each handler is a REST method with some endpoint URL. The request, response, and context are used to create a response. The context creates a status code, and then a JSON content body. This is one of the things that you need to do when implementing is to create a static mock service worker in your public directory. So you just run npxmsw in it. Public, depending on what framework you use, and this creates this mock service worker in your public directory to get the code. Then you get all of the handlers. You wrap them in the setup worker, which sets up all of the interceptors, and then you start it anywhere. Well, depending how you run it, but I run it in the browser, so you just start it anywhere in the front end code. So there are some pros and cons, and so the cons really aren't that jarring. The SSL, I tried to make it work with an unsigned certificate, and it didn't really work that well. So there are some kinks in the implementation if you want SSL, but other than that, I think it's even the maintenance of the handlers is worst case scenario a mock endpoint won't work. But it's mainly I'd say in the pro column. I think that they're a nice library, and there's like a little demo, which is you have start. You can see that here's some unimplemented data endpoint is not present, and then because this is the browser, we can start the mock service workers, and then they will intercept the endpoint and provide the data. And if you have questions, then sorry.
Zoom.
Oh, zoom into. Yeah, it's just a
console.
Right?
Zoom to the console.
Oh, in the console.
Yeah.
Maybe I can do this.
Command plus, yeah.
You need to click in the console first and
Yeah.
then Command plus.
Yeah, yeah. Okay.
Yeah.
Yes, there it is. So yeah, this is where the mocking is started. This is where it's intercepted, and yeah, that's all I have to say about that. If you have any questions, then let me know.
Can you talk about how you would run it on the server?
On the server, yes, it's this will require didn't prepare this part actually. I think in the started. Yes. So yeah, and integration there. It's pretty much. I mean, you can you yeah. Actually, I haven't prepared that part, but yes. Any other questions?
If you want, I can.
Yes, I think.
Yeah, sorry.
Yes.
Sorry.
So maybe you can direct the questions to him. Answer them better than I can.
Yeah, I was working on the customer part, not with it. Piotr says, pretty happy with it. Yeah, so there are two integrations. There's the browser, which is like local development, and then the node server is what Jest is going to be using. That was surprisingly easy. So we have like a setup file that is running before each test week start. And Jest started, and that registers the node server very similarly to how the browser is doing. Basically two files, one for initializing the browser for local dev environment, and one for initializing.
Yeah, what he said. Yes.
Do you mock all your APIs or your endpoints?
Right now, we don't. We intend to mock it in the project that I'm working on, but we are kind of borrowing a lot from what Lars here is working on, and that is he has some wisdom to impart on us, and I think that we will be using them when migrating from the Ruby to like hopefully a standalone application at some point, and that's why we were looking into this. Oh, sorry.
How do you ensure that the typing is correct? I mean, how do you ensure that what the server sends is still what you mock?
What we mock, there are actually mock types in that they provide, which, to be honest with you, I still haven't gotten that. I don't have that much experience with it yet. So, but there are types that the framework provides.
Yeah, just replying to that. So one way to do that is to generate types for your APIs, and then annotate your sorry, your handlers the data with that type, so you ensure that they match.
Yeah.
But that kind of defeats the purpose of not having the endpoint yet. So if you want to use it without having the endpoint yet, there's a risk that you end up like coming up with data that looks nice for the front end, but it's actually not what the backend is going to send you. Yeah. So you still have some integration work to do.
Yeah. I'm not sure. I know that it has a pass-through feature. Is that what you're asking? Whether if you have an endpoint that already exists that you want to modify, or is that? Oh, okay.
Yeah, actually, I've actually been struggling with that because we have some flaky tests that are failing on loading indicator. So in CI, it's running faster than running local depth. Talking looking into that. But there is like a delay that you you return a response in the mocking handlers, you call the response function. And you can pass in a context array. It has some default value. I have to look in the source code to actually find default values. It's fairly small, but it's a bit randomized. You can also pass in milliseconds if you want. It depends. Yeah, well, like you could. No, I mean it's very quick because it's a service worker running in your browser, for example, or in a node in parallel. So the actual execution of the mock handler is very very small, but it seamlessly integrates into your fetch chain. I'm not sure if it might be the problem might be that you can't mock the promise result, but if you have a query fetch or something, then MSW is kind of interested in that without you having to do anything with the content.
Can I follow up on that? So this scenario we were describing is like orchestrating when will the promise be resolved, so you can verify that the loading state is correct. And using fake timers is actually, I think, the only real good way to do that. So you have to use fake timers in that test, and then use the delay. But then you can not progress the timers and verify that it still say loading. And then when you progress the timers afterwards, then you can verify that it's now fully loaded. So you can control it like that, and it will still be fast because the timers are okay.
That's your next program.
But don't you run into the problem there where different platforms actually run different nodes at timeout? Because you're pretty much orchestrating your entire testing setup on set timeout and things running in SQL. And different platforms on the node, you use different signal timers. So you might have something that works perfectly on your local machine, but you actually need to restart the pipeline 4 times on Azure before it actually deploys. And it's just like restart it again. Yeah, my test finally succeeded. And if I'm sitting there as a developer, I just say I don't care. I need to move things to production, and if it's working 1 time out of 4, then no.
But when you're using fake timers, you don't actually ever get timeout errors. So
but fake timers works differently on the Windows and Linux. So there you have a platform difference.
Not my question.
Yeah, but one uses M timer and uses.
It's just the JavaScript runtime timers that are being mocked. Okay.
We can discuss that in this section.
Yeah. No, but.
All right, let's give a hand. I'll try to wrap it up. So today, in this wonderful world, you learn how to become not only a digital nomad, but also a very performant digital nomad, right? So you can work without APIs, you can mock stuff, that's very amazing. And then you can also like write very, very fast tests. Thank you, Lars. And then those tests could also impress all of your colleagues when you throw them in the pipeline, huh? And save the costs of running things. And last but not least, a digital nomad should know Remix, right? It's Remix is cool. Like that's why Vercel just tried like to just steal it. So they called it Next 13, right? Yeah. It's that's pretty sweet. Thank you so much. Anyways, see you on the 22nd on the Remix meetup. And yeah, now it's time for food and drinks. Thank you, InPay, for hosting us, and Isabel for organizing everything. Lovely.
Thank you.